So you may have heard that we at Google have trained over 17,000 of our employees in something that we're calling decision intelligence. What is that? You can think of decision intelligence as data science plus plus. It's applied data science augmented with the social and managerial sciences. But if you really want to understand what's at the beating heart of this discipline, it's the reduction of type 3 error. Do you remember your errors from statistics, data scientists? If not, that's okay, I've got your back, I'm a statistician, so let's have a quick refresher. Type 1 error, incorrectly rejecting the null hypothesis. Type 2 error, incorrectly failing to reject the null hypothesis. And type 3 error, correctly rejecting the wrong null hypothesis. Or if you prefer the Bayesian statement on the same thing, all the right math to solve the wrong problem. Now, our discipline, data science, it's not immune to this. And this gets brought up in your stats class, and there are a few giggles, tee-hee-ha-ha, and then it's forgotten, right? It's brought up as an emblem of, hey kids, we should kind of solve useful things, rather than spend all this time meticulously, mathematically digging down the wrong rabbit holes. But after it's brought up that way, it's entirely forgotten. And chances are it's never brought up ever again, and there's just some, I don't know, maybe vague hope that you go and you learn how to pick good, useful problems that are worth the time of all this complicated math that you end up mastering. But really, what's the plan there? I mean, really, think about what those data science courses teach you. They teach you that nitty-gritty. But if you apply it to the wrong place, what good is it? And I also want to point out that the stuff that you tend to learn in your core data science stuff, in your AI courses, in your statistics courses, think of that as being symbolized by that little red velvet book in the middle. And the entire shell, in order, is what you need to know to actually apply this stuff effectively, usefully, and safely in real life. There's a whole lot of stuff that you need to know. What you're learning is right in the middle, and perhaps a little bit scarily for you, your skills are really at the mercy of those bookends, which tend to be handled by other job functions. At the beginning, decision makers. At the end, reliability folks, software engineers, and this stuff that you learn is right in the middle. And if all that other stuff doesn't get done well, and if the baton isn't nicely passed to you and from you, the whole thing runs to nonsense. So that's what I want to talk to you about. Before I do that, I want to also talk about the future. The future that we are getting for sure, that we are on track for, is a future where there is an abundance of methodologies. And this methodology stuff is also where your courses focus and perhaps over-focus a little bit. Because in the old days, when all of this was just one big research dream, there weren't the algorithms and equations yet, and so you can think about applying them usefully. But now, thanks to the efforts of researchers, we can now all start standing on the shoulders of giants. And at Google, we certainly do this. We have a really large research team which develops these fundamental methodologies, and now that we're focusing on application, we go and we use that stuff that they make and we apply it within our products. I can't think of a single one of our consumer products at Google that doesn't have machine learning or AI in there somewhere. Another part of the for sure future, nope, we're stuck at this future. No more future.
Next slide.
Okay, awesome. Yeah, so I'm gonna click like this, so you pretend I clicked and it was actually whoever in the back. Never mind the man behind the curtain, right? Okay, so the other part of the future that we are definitely getting is that we have an acceleration of data collection. That's a fact. More data, and in fact you could get these jobs that are about big data this, big data that. Just a move the stuff around. And additionally, we're getting easier tools. See, it's all good and well when the researchers come up with these shiny, bright ideas, but if the world can't use them, then again, they're not really, they're not as good for us as they could be. Now, the wonderful thing about humankind is that when someone comes up with some tool prototype and it has potential, then some other someone, engineers, often in the open source community, will go and take that dream or sketch that a researcher has come up with and actually turn it into a tool that is not a pain in everyone's neck to use. And so, with better tools, you don't need to go and recode all that stuff directly from the research paper from scratch yourself. You can kind of just, pick it up off the shelf and use it. I mean, think about some examples. Think about what Kubeflow represents, for example. Data scientists know all about Kubernetes and containers. Yes, yes, yes? Now, what Kubeflow is all about is it's a project that gives you containerized machine learning without you, the data scientist, needing to know anything about this stuff. You just get your composable, scalable machine learning just sort of ready to go. You get your Jupyter notebooks after you've run a one-line setup script. Now, remember the days before Jupyter notebooks? Before notebooks at all, right? That's easier tools again. Those days were miserable. Oh, the tools are getting so much better. Another example is being able to actually skip the whole machine learning thing and AI thing entirely and just go and use models that other people have made for you. I mean, that's actually what the Google Cloud machine learning APIs are about, and we make it sound a little bit like you're doing machine learning by using them, but actually, we've already done the machine learning. We've made the thing for you, and now you can just kind of shove your data in and get your answers out on the other side. Way easier than having to build a vision system from scratch, right? So, in addition to that, not only do we have these easy tools that allow people with less expertise to become architects of their own bright futures, but we also have more democratization. And true democratization is more than just more textbooks or blog posts or videos, talks, information about this stuff. True democratization is allowing everyone to really get their hands on the steering wheel, which is why this becomes a cloud story. Simply put, in the old days, you wanted to try out deep learning, you had to build your own data center first, and not everyone could afford to do that. But now with the clouds, you can just borrow someone else's data center for a little bit and give it back when you're bored, right? So this lets more people get their hands on the steering wheel. So amazing stuff. More people are going to use this. What are they going to be using it for, though? Now I don't even know if I'm doing it or if it... Nope, not me. There you go. So, what are they going to be using it for? Well, wherever their creativity takes them. I'm going to show you some examples of real things that have been done with machine learning on Google Cloud Platform. So, imagine a family of cucumber farmers where the son doesn't want his aging parents to have to spend so much time sorting cucumbers by hand. He goes and he creates a solution that does the sorting for them. Or a large Japanese baby food products manufacturer now checks ingredients as safe or spoiled, not by having to taste or smell each one, but by letting a machine learning system do it. Or think about the task of making high-quality satellite image maps. When it's got cloud cover over it, it's not such high quality, turns out. So you do a few flybys, and then you want to remove the cloud pixels, but you want to leave the snow because that's working as intended. And you don't want to have to figure out those white pixels by hand and separate them. So instead, you prefer to automate it. So that's a thing that you can do with machine learning. This is great. Okay. There you go. Now, another application that we did at Google was giving control to an AI system of our data center's cooling. Now, you could do the traditional data science approach for this, and you get data scientists to go and look at all the data and look at all the things going on in the data center and find some way that you might recode those traditional software systems to be a little more energy efficient, right? Energy efficiency is good. And when humans did this, if a data science team got you like a 1 or 2% improvement in energy efficiency, it's a big deal. And it should be a big deal, right? 1 or 2% energy efficiency improvement for a data center, that's quite a lot of money saved and quite a reduction in carbon footprint. Now, when we handed this over to an AI system, any guesses what the energy efficiency improvement was? For those who haven't actually looked up the number. Any guesses? What's that? 7%. 3%. Going once, going twice. 12! Whoa, 12, very nice. And the answer is 40. Yeah, exactly. I can't do the wolf whistle like that, but I would if I could. Still practicing in my spare time. Yeah, exactly. Huge reduction in carbon footprint. Really great for the world. You could automatically caption this speech that I'm giving. You could also, in real time, convert it to German. You could do that with AI. You could play the winning move in a game of Go against a world champion. Also a real application. Or you could build a car that drives itself, right? Really futuristic application if you thought about it 10 years ago, and now it's something that we take for granted as being part of our lives. So with all this potential, there you go. With all this potential, why do businesses fail at machine learning? I mean, you'd think. The future is here, we've got the tools, they're getting easier, we've got all that abundance of algorithms. Why are businesses failing? Well, I think it's because when we say AI or when we say machine learning, we make it sound like there's only one discipline here, but actually there are two. Right? Two machine learnings, two AIs. They are as different from one another as building microwaves from scratch and innovating in recipes in the kitchen. So there's an applied side and a research side. And what we're not doing is really recognizing how different those things are and evaluating what our courses teach us to do. The courses in university, if you've taken data science programs, anyone been in a data science program? Yeah, quite a few hands, yeah, or statistics or AI, right? Those courses, they tend to focus on how the microwave is wired. And look, if you want to be a researcher, you do need to know that stuff. Because what do researchers do? They build general purpose tools, not specific to a particular business problem, but general purpose, for other people to one day go and use. And you don't have to worry about how it's being used right now. You're just going to make sure it works on a benchmark data set. That's fine. It's a general purpose thing. You don't have to worry about the application, right? So you are making the microwave. And to make a better microwave than this one, because this one's pretty sophisticated, you're going to have to know how this thing works. How are you going to build a better microwave if you don't? Right? So of course, you're going to have to start from scratch from how wiring works and electricity and all that, right? If you're building microwaves. That's a particular kind of business. That's the research side of AI and machine learning. But let's face it, today, there are warehouses upon warehouses of these things already made. And many of you, you just want to get cooking already. You want to make a specific kind of innovation in a recipe. That's what you're serving. You're serving dishes, a specific kind for a specific restaurant, a kitchen at scale. Now, turns out that is a different job from building the microwave, right? Running a kitchen at scale with innovative recipes, making microwaves from scratch, totally different things. And a big reason that businesses fail at this stuff is they end up trying to staff their kitchens with 20 researchers. That's like hiring 20 folks who have been building microwave components their whole lives, expecting them to now run a kitchen and cook. What could possibly go wrong, right? Because those folks are not actually trained in anything to do with the applied side of things. I mean, there's a lot to worry about. The logistics of getting your ingredients at scale, of checking your ingredients, of preparing your ingredients. You don't learn about that when you're building your microwave. Or figuring out what your customers might want. Doing the taste tests for it. Having a principled way to tinker and dabble and try out all the available appliances. I mean, say you want to make an edible sock that tastes like pizza. In what order are you going to do that? And how does it really help you to know precisely how the microwave is wired? Totally different discipline. And we're not talking about this, but we should be talking about this. Because the world is building more microwaves, encouraging you to know how to do that from scratch yourselves. It's not training anyone how to use them. As reliability folks at Google like to say, hope is not a strategy. What is the plan there? I mean, come on, do we just hope that we're going to hire a microwave builder, an engineer, a researcher, and they just transcend out of that? And suddenly learn how to really appreciate cooking at scale without being taught at all? Seriously, hope is not a strategy. Oh, third time to jump. Hope is not a strategy. And we all make it worse, I want to point this out, by over-focusing on just how, cool we feel because we know how those nitty-gritties of those algorithms work. You strut around so proud of yourselves, understanding backpropagation. That's coded up for you. You don't need to know how backpropagation works. But please tell me you know how to cook at scale if that's what your job is. And when businesses don't understand which job they're in, are they building microwaves for other people? Are they building recipes? Big problems happen. And at Google, we're trying to address this by training people in decision intelligence. And we are renaming this applied AI thing. First, we're recognizing that you do have to augment it with ideas from managerial and social sciences for it really to be effective. But we're also renaming it from just applied AI to its own, its own discipline and its own name. Because if you don't do that, what do researchers say? They're like, oh, you mean you're talking about all just the footnote to what we work on? Oh, applied AI, that's just the footnote. Of course, if we know how to build the microwave, we know how to run McDonald's. Exactly, my friends. So I hope that you'll be inspired first to ask yourselves, which business are you in? Or if you are a business leader, you'll ask yourself the same question and then make sure that you hire the right people with the right skills. And if they don't exist, come on, people, let's start training this. Now let's talk about why we actually get so excited about machine learning and AI in the first place. And I use those terms interchangeably because frankly, that's what the industry does. When AI was originally named, it was named aspirationally, and no one really knew how the brain worked or could define intelligence in a satisfactory way. And anyway, the definition of intelligence keeps morphing, whatever these. Today, the way that AI tends to be used is synonymous with deep learning, and deep learning is a type of machine learning, but then industry just uses them interchangeably, and you know what? That's fine. From an applied standpoint, it really doesn't matter, because you're going to start your project the same way. It doesn't matter if it's AI or if it's machine learning. you'll just end up finding out whether you need the deep neural network algorithm as you tinker and dabble in the kitchen. Cooking's cooking, maybe you'll need a microwave, maybe you won't, you figure it out later. So let's talk about why, oh, I can't believe that worked. So let's talk about why we're actually excited by this AI machine learning stuff. We used to be excited by it because we just tagged it all with as much science fiction as we could. Because frankly, it wasn't that useful or that practical. So what's the only way to get grants? Right? Is if you make it sound way fancier than it is. Because you can't argue the usefulness. But now, today, I propose we just clean the slate. Today, it actually is really useful. So instead of still having to point to science fiction, which is a terrible teacher most of the time, let's instead point to what you can do with it. And so what can you do with it? What is the point here? Well, the point is that in traditional programming, how do you solve a problem? This is about thing labeling, right? This whole software stuff, in come some inputs, out comes some output. Something happens in the middle. What happens with traditional programming? With traditional programming, to solve the task to create the code that turns the input into the output, the programmer has to communicate in some way with the universe, right? Channel it real hard. And then handcraft those instructions themselves. And you don't even want to think about how complicated the algorithm is, right? Software engineers that come up with those, that model those instructions. In machine learning or AI, we don't handcraft those instructions anymore. Instead, we use examples to express our wishes, and the algorithm then finds patterns in those examples and outputs instructions for us. So, in some sense, if you want to know who's getting replaced by machine learning and AI, right, what's being automated, it's the software engineer that's getting automated. But never fear, software engineers, because of the proliferation of data, there is plenty of coding for you to do in the sense of explicit instructions of go look at these data, right? Moving data around now becomes your main job. So what we're really doing here is we're finding a second way to express our wishes. Instead of telling how the task should be done, we're giving examples. And I want you to notice that as humans, we already express ourselves in these two ways. Sometimes it's easier to explain what you want with exact instructions. Do this, then do that, then do that. And sometimes you prefer to say, here, look at some pictures of my friend, look at some pictures of not my friend. Okay, go figure out yourself how to identify my friend when you need to pick them up at the airport, right? So, in other words, this is an ungagging. We can now, I didn't do anything here if you're giggling at that. In other words, we can now express ourselves both ways to computers, and that is the magic. But because it requires examples to tick and the processing power to move those examples around, it's only really becoming viable and practical today. The algorithms have been around for a long time. Now, what the real magic here is sometimes for some tasks, the instructions are just so darn complicated that you cannot come up with them yourself. I mean, think about the task, which we know works because you use Google Photos, right? You put in cat and it brings you up pictures of cats. What is it that your brain does with those pixels to get from the pixels to the label cat? How do you code up that task explicitly? Oh dear. So you can't express what those instructions should be. They are, in other words, ineffable. And what AI and machine learning let you do is automate the ineffable. That is the point, and that is the magic here. That's what's so exciting. Never mind that you can't say how to do the task, you can get it automated anyway. But once the instructions get so complicated that we have to rely on using examples, we can't grasp those instructions, right? Like, by definition, you have to go to AI. You can't do it some other way. When those instructions are so complicated you can't wrap your mind around them, then you won't know how it works, kind of by definition, right? I'm saying eventually things get so complicated that your brain can't wrap itself around that complexity. A computer has better memory storage in some sense than you do, and so you're going to need the computer to carry that really long, complicated set of instructions because you can't. Well, you don't know how it works then, right? By very definition. So how do you trust it? I propose to you, you won't trust it blindly because that's just a stupid thing to do. Blind trust is terrible. Instead, what you're going to do is you're going to test it. I want to give you an example to connect this emotionally. You can choose between two spaceships. One of them, you know exactly how it works because here's binders all with all the physics of how it works, but it's never flown before. The other one, it's a mystery how the thing flies, but it has flown many, many times in the same conditions that you're going to go in. No accidents, always successful. Which one are you going to pick? It's a philosophical question, I can't answer it for you. But since I'm a statistician, maybe, I prefer the testing as a basis for trust. And think about what you do with human students. You do the same thing. You don't go and poke around in your calculus students' cranial wet stuff to figure out how they're doing the calculus, right? And that's the equivalent of opening up the model and seeing how it works. Instead, what you do is you construct an exam for them, wisely, carefully, with relevant examples, and then you check that they actually can do the calculus, right? And you use new examples to beat overfitting, because what's overfitting? It's essentially memorization. Your student can memorize their way to victory if you give them the exact same questions they studied from on the final exam, so don't do that, very simple. So it's well-crafted tests that are your best basis for trust, and we take this really seriously at Google. Now, what I'm not saying is that interpretability isn't important. Actually, when you hear these interpretability debates, it tends to be researchers arguing. And the argument melts away when you take a practical view, an applied view. Because if your goal is inspiration, that's actually analytics. That's not machine learning and AI. You can use the same algorithms for all the different areas in data science. So if your goal is to get inspired, then of course you need interpretability and explainability. How are you going to get inspired from a black box? But if your project goal is performance, well, in that case, when you take models that you can wrap your head around, you limit the class of potential solutions, and you limit them to really simple things, and sometimes you need a more complicated solution that you can't wrap your head around, and there you go, giving up performance. If your project really wants both, then you got to optimize for both goals at once, and you'll probably end up doing worse than if you had only one goal, as you know. So really, from the applied project side, there is no debate. Did you need inspiration? Well, of course, then you need something that can give you inspiration. Did you need performance with no inspiration? Well, go all in on performance, and sometimes that means that the thing is too complicated to wrap your head around. But I want to ask you, if performance on well-crafted tests is the best basis for trust, who is designing your tests? Who is saying what it means to succeed at your task? Who is setting the minimum bar, the passing grade? That's the decision maker on your team. Are they skilled? Do they know how to do it? Because it's all good and well to give an exam, but if the exam is stupid, then you're going to release a system that also could be dangerous or stupid. And to really drive home this idea about decision makers, I want to ask you this. What is better, a reliable worker or an unreliable worker? If you're saying for sure a reliable worker, I want to caution you. It really depends on the quality of the decision maker. Because a reliable worker is going to very quickly perform and do exactly what it's told. And AI is the ultimate reliable worker. It will very quickly scale up an intelligent decision maker. But similarly, if it's a fool giving the instructions, then it will scale up that foolishness, kind of like that in coffee shops. Coffee making you do stupid things faster, right? So you really want an unreliable worker if you have a bad decision maker, right? that'll be self-limiting. And the reason you should fear AI is not all this robot stuff. You should fear it like you fear any technology that has the ability to scale quickly. Technology is a lever, and I really want us to stop using words that make it sound like technology is independent of humans. Technology simply echoes the wishes of whoever built it. But sometimes that technology, it echoes for a long time, and it is a very powerful lever that moves the world very quickly. It really matters who's on the end of that lever. And my final thought for you is that if you are working in data science, you are building levers. Bigger, 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 bigger levers. You are essentially proliferating magic lamps. And it's never the lamp or the genie that is dangerous. It is an unskilled wisher. The person at the beginning of the project who says why the project should exist, who points the thing in some direction in the first place. If that person doesn't know how to wish responsibly, it's a complete disaster. And we haven't been training those people. Because in the past, without technologies that are such big levers that scale so much, bad decision-making was self-limiting. You just did a little bit of local damage and you got taken out by nature. But today, that's changing. We really need to think about who it is that is driving these projects, and do they have the skills? And so the future that we're getting for sure is this one. Lots of algorithms, which is probably what you're all focused on. Lots of data, easier tools. But what I hope we'll build together is a better future that also has more data literacy so people can think simply about the basics of learning and teaching about what it means to build scalable technologies. More diverse collaboration, because it takes teams with a diverse skill set to do this properly at scale. Better process. And then, maybe best of all, skilled decision makers who have the ability to wish responsibly, so that at the end, we have good, responsible wishes fulfilled. Because tomorrow's AI will be built on what we do today. So, thank you very much.